Right, this is the 09C video on work and power. We're going to understand the concept of work. So the agenda for today, we're going to do the stair challenge, introduce work, and go over some work examples. So there is, watch the introductory video for the announcement, all the assignments, and any additional announcements. So the big question for today is, does the sun do work on the earth? So remember, there are codes in the video, the A, B, and C. There will be two codes in each video. One will be a written code on the screen. The other will be a verbal code said by myself. Each code will be 3 numbers. You will need all the codes in order to move on with the homework assignment. So remember, just write what is in green. That just summarizes everything that you need to know. So this is the video 09C written code. It's 193, so the written code is 193. I would recommend you writing that down somewhere. All right, so let's talk about work. All right, now in general, from a physics standpoint, doing work is the act of changing or transforming energy of an object. And we learned about energy change versus energy transforming. Now, if work is the act of changing or transforming the object's energy, then what do you think the unit for work is? Well, the unit for work is going to be the joule, because you're changing energy. I like to think you're either giving that object energy or you're taking it away. So we're going to explore that when we do the stair challenge. So the challenge is to basically do the most work by running up the stairs. All right, so recall that if a force is applied, the object will change motion or accelerate. And if an impulse is applied, then the momentum will change. Now, if work is done on an object, then the energy of that object will change or transform. So we looked at Bob the anvil. You raised the force by applying you raised Bob by applying a force through some displacement. Thus, you gave the brick some energy, or you gave the Bob some energy by doing work. Likewise, when you applied a force through some displacement to accelerate Bob when you're pushing him on the table, you gave the brick some energy by doing work. So, therefore, physics type define work to be the scalar product of force times displacement times the cosine of the angle between the two. Now, just write the equation down. So you can see here that's the absolute value of the force, absolute distance, times the cosine of the angle between those two. Now, I know it looks confusing right now, but it is a lot easier than it looks. So this is a video of somebody trying to push a box and they don't move it. Well, is the person applying a force? Well, yes. Now, does the box move through some displacement? Well, no, the box doesn't move. So no force would have been done because the box didn't move, right? So thus, to do work, two conditions must be met. A force must be applied and the object moves in line with the force. So what this equation means is that to do work on an object, to change its energy, a component of the force must be applied in the direction of the displacement. So if you push an object, it has to move at least in some part in that direction. Perpendicular components of forces to displacement do no work. Components parallel to displacement do work. Right, so if we look at this equation, what this means is that, let's look at this. Well, if the angle is 0 degrees, so it's in the same direction, the force and the displacement, the same direction, well, its work is going to be positive. If it's opposite direction, so 180 degrees, it's going to be negative. Well, if it's perpendicular, it's going to be 0. All right, so work done on a body can be either positive or negative. Now, you probably say, well, why? It's scalar. It doesn't have a direction. Well, it's if the force is in the opposite direction of the displacement, right? So let's just simplify a little bit, right? Positive work is done if the force is applied in the direction of motion. Negative work is done if the force is applied in the opposite direction of motion, and no work is done if the force is applied perpendicular to the motion. So all that might be a little confusing, but we don't need to worry about that cosine if we just remember this, right? Because all the angles that we're going to talk about in this class are either going to be 0, 90, or 180. All right, so same thing with this one. So positive work is done in the direction of motion, negative work. So is the person doing positive or negative work? Why? Is the friction doing positive or negative work? Is gravity doing positive or negative work? Why? So we look at somebody lifting an object or like a weight, right? So if we look at somebody at deadlift, let's just look at that person lifting the weight off the ground. Well, I know that that person is going to be doing positive work because the force is going to be in the direction of the motion. Now, gravity is going to be doing negative work because gravity is pulling in the opposite direction of motion. And as the barbell, as he's holding it at his waist, well, there's going to be no work being done by gravity or the person because it's not moving. And then as the barbell, if he drops it, right? Well, the person well, isn't going to be doing work because they dropped it, right? That's really not applicable here. But gravity is going to be doing positive work because now it's speeding up. The force is in the direction of motion. So gravity can do positive, negative, or zero work depending on the motion of the object. So I play this clip of these deadlifts where the person doesn't lift the object. Well, no work is done on the object if if that barbell doesn't move. All right. So at this time, I'll give you the verbal code. It is 054. The verbal code is 054. All right. So let's look at a pendulum. So the forces that are going to be applied are going to be gravity and the string, that tension of that string. Now, let's look as it is swinging down. So I recommend looking at that, clicking on that link that says pendulum and just playing around with it because it'll show you the force and it will show you the velocity. This one shows you the velocity and the acceleration. Now, as it's swinging down, it's speeding up. So just a good rule to follow is that if it's speeding up, well, it's positive work. So gravity is doing positive work. Now, is the string doing positive or negative work? Well, that one's tricky. I'll let you figure that one out by looking at that pendulum. Now, if you look at the pendulum as it's swinging up, well, gravity is going to be slowing it down. So, yeah, gravity is going to be slowing it down. So it's going to be doing negative work. Now, let's look at the pendulum as it is swinging to the equilibrium position. So at the very bottom. Well, this is the tricky part, right? So I'm going to tell you at the very bottom, there's going to be no work being done on it because both the string and gravity are perpendicular to the motion. So there's no work being done at that point right there, like that instant in time, right? So the work being done to bob on the pendulum depends on the position along the path. But like I said, I'll tell you to wait till later. The string isn't going to be doing work on that bob on the pendulum because at every single point along the swing, that string is applying a force perpendicular to the motion, right, at every single point. But gravity is going to be positive, negative, or zero, depending on where it is on its swing. All right, so how can a pendulum prove the Earth rotates? It's just a little fun fact about about how a pendulum proved that Earth swung. Now, let's get back to does sun do work on the Earth? So the thing is that you would think no, right? You would think that, well, if it's circular motion, that means the force is always going to be perpendicular to the motion, right? But Kepler's first law says that all planets orbit in an elliptical path, right? So that simulation will show it, and you can play around with that one. Now, the one force that's being applied is the sun's gravity. The sun is pulling on the Earth, and that's it. Right now, the Earth's orbit is not perpendicular. Now, let's look at the Earth as it is slowing down as it moves towards aphelion. So that's the farthest point away from the sun. So that's where it's slowing down. Now, gravity would be doing negative work because it's slowing it down. Now, let's look at the Earth as it's speeding up close to perihelion. So that's what that's the closest point to the sun. Well, gravity is going to be doing positive work because it's going to be speeding up. Now, at those exact points, at aphelion and perihelion, where it's either the farthest or the closest, those exact instances, gravity is going to be doing no work because at those instances, the direction of the motion and the force are going to be perpendicular, right? That sums it up. All right, so there are the links for the day. There's some extra videos in there for you. And as a final thought, remember there's too much unknown in the universe to take a break from learning. Get out there and question everything.